tidak berhalangan biar langsung nyusul gitu ya.
Ya.
Baik, selamat siang Pak Deputi, Pak Dr. Haris Gunawan, Pak timnya Prof. Emil Salim, kalau nanti hadir biar nyusul, Pak Profesor Azwar Maas, serta para hadirin, Bapak, Ibu, Saudara-saudara sekalian. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Salam sejahtera bagi kita sekalian. Om Swastiastu, Namo Buddhaya, salam kebajikan. Pertama-tama, marilah kita mengucap syukur kepada Tuhan Yang Maha Esa karena berkat rahmat dan kasih karunia-Nya kita bisa bertemu dalam forum diskusi terfokus ini. Meskipun kita tidak bisa bertemu secara fisik, tetapi secara virtual kita tetap bisa bertemu dan berdiskusi. Ini menurut saya sesuatu yang istimewa juga, dan dengan teknologi kita bisa bertemu dengan siapapun dan dimanapun. Ya. Ini patut kita syukuri. Mohon izin untuk welcoming Profesor Hans Joosten. Good morning, Prof. Hans Joosten.
Good morning to you all. Glad to see you all around, so many.
Yeah, I know that it is still in the morning at your place, but in Indonesia we are now already in the afternoon. Yeah, I just greet our Indonesian presenters and all participants. Thank you for joining our discussion, Prof. Joosten. It is our honor to have you in this discussion. Let me introduce all presenters in this discussion and myself. My name is Nugroho from Badan Restorasi Gambut or Peatland Restoration Agency in Indonesia. I will serve you to facilitate this focus group discussion. Now I would like to introduce the presenter. The first presenter, if Professor Emil Salim is coming, we will welcome Professor Emil Salim. He is a former Minister Environment of Indonesia, but he is well known as environment expert in Indonesia. We expect him to give point of view on environment in tropical peatland ecosystem management and restoration. We hope that he is able to come along in this discussion. The second will be Dr. Hans Joosten of Greifswald University in Germany. He is well known as a subtropical peatland scientist in Europe. We hope that we can get perspective on subtropical peatland ecosystem management and which we can be adopted in tropical environment such as in Indonesia. The third speaker will be Dr. Haris Gunawan. He is a Deputy of Research and Development, Peatland Restoration Agency. We hope to get explanation how scientific approach on peatland can be used to develop policy and implementation of peatland restoration in Indonesia. The fourth will be Professor Dr. Azwar Maas, Professor of Soil Science at Agriculture Faculty, Gajah Mada University in Yogyakarta, Indonesia. Yeah. He's also the chief of expert panel of Peatland Restoration Agency Indonesia. We hope to get information on tropical peatland ecosystem management from soil scientists' point of view. Today, we are carrying out the first of scientific discussion that we plan a series of 11 discussions until the end of October 2020. The topic today that we are talking about is exploring science of tropical and subtropical peatland ecosystem management and restoration. The purpose of focus group discussion is to get information of scientific aspect on tropical and subtropical environment for policy development and implementation. By the end of the series, that we will develop the roadmap for research that will be applicable to support the implementation. I will speak in two languages, Indonesia and English. Untuk bapak-bapak presenter dari Indonesia, silahkan nanti menyampaikan materinya dalam bahasa Indonesia. Saya akan ngomong campur-campur. Kalau nggak bisa Inggris ya saya Indonesiakan. I should tell to Prof. Hans Joosten that almost all of our participants in this discussion are able to understand English. So you can give presentation in English, and you don't have to translate.
Better than that I have to do it in Bahasa.
Yeah, you don't have to translate to Indonesia. Yeah. Okay. This discussion will be divided into 3 sessions. The first session, each speaker will be provided not more than 20 minutes to present his paper. And the second session, speakers are pleased to give opinion, suggestion, or comments to other speakers so that we can explore the presentation more deeply. Yeah. The last session, the third session, we are pleased to invite participants to give comments and ask questions for general discussion. So we are not only explore the presentation, but we also can explore the knowledge from the participants. Jadi nanti ada 3 segmen setelah presentasi masing-masing 20 menit, presenter kami persilahkan untuk bisa memberikan komen, mengomentari pembicaraan yang lain sebelum memberi kesempatan kepada audiens. Untuk kesempatan pertama, karena Prof. Emil belum hadir di antara kita dan masih mengatur waktunya, kami akan persilahkan the first speaker is Professor Hans Joosten. It's your turn, Prof. Joosten. It's about 20 minutes. Yeah.
Okay, so I'm going to share my screen with you. I'll try that.
Yeah.
Huh? Let me see whether that works. So, yes. Then you have to say whether you see what. Do you see my screen now?
Not yet.
Yes.
Okay.
Not yet.
Yes.
Okay.
Yeah.
Yes.
Okay.
We can see
here?
now.
Yes.
Okay, so then I can do it myself.
Yes.
I want to give you a more or less a general introduction in the problems that we are involved in, under the title Wise Use of Peatlands Worldwide. As we all know, our planet is getting warmer and warmer. That is happening everywhere in the world. This shows every country of the world how over the last decades the average temperatures are increasing. This leads to decreasing food and water security and growing social breakdown, conflict, and migration. The frequency and severity of disasters are rapidly increasing with enormous losses of lives and money. Every year it becomes worse. And these developments, and that is what all countries of the world have unanimously agreed, have to stop. That is the major decision of the Paris Agreement in 2015. We have to stop these developments. So actually we can say that Paris has made the world rather simple. Since Paris we have, all countries of the world, one common goal: to limit climate change to less than 2 degrees centigrade in average, and preferably to 1.5 degrees. The Intergovernmental Panel for Climate Change has, in its 1.5 degrees report from 2018, spelled out what this means. It means that emissions of CO2 have to be 0 in 2050, that CO2 has to be a net sink after 2015, and that other greenhouse gases like methane have to be reduced with 50%, and nitrous oxide, N2O, with 20%. This is already an accommodation of the Sustainable Development Goals, because it is very difficult to reduce methane and nitrous oxide without reducing food security. That's why the focus is on CO2.
Besok ini kayak gini lagi.
The Paris Agreement and also the Sustainable Development Goals have said it is not only climate where we are talking about. We have to see this in the context of sustainable development and efforts to eradicate poverty. So it is always the combination of climate, food security, etc., etc. So the challenges are enormous. This means that we have to break radically with wrong development from the past, also with respect to peatlands. We all know that peatlands, living peatlands, which we call in English mayas, are ecosystems in which the production of biomass is larger than the decay, and as a result, dead plants accumulate as peat. This is nicely shown in this picture from Georgia. You see the plants, you see the water, and you see the peat where the water conserves the dead plant remains. So water is very crucial. Peat accumulates actually only through water saturation. But if the peat remains water saturated, it keeps on accumulating during thousands of years, and in this way it stores concentrated carbon in thick layers. Annually, the sequestration of carbon is not that large. All the peatlands of the world that are growing, and 80% of the peatland area of the world is not drained yet. These 80% only compensates for 1% of the annual carbon emissions from burning fossil fuels. So peatlands are not going to save the world. We have to reduce also our other emissions. But peatlands are very important. They are most important because they have an enormous carbon stock. Peatlands are the most space-effective carbon stores of all terrestrial ecosystems. By the way, people say that there are no peatlands on Java. This is a picture from Rawalabok I made a few years ago, which is thick layers of peat. Worldwide, every hectare of peatland in average has the same amount of carbon than 2 million liters of diesel oil. So the carbon content of peat worldwide is enormous. To compare it with forest, a 15 centimeters thick layer of peat contains per hectare already more carbon than a high carbon stock tropical rainforest. So in climate negotiations and politics, there is a lot of attention to forest, and it is good that it's there because deforestation is a major problem. But a small layer of peat has already more carbon than a tropical rainforest. So peatlands have to be treated with utmost care. Although they cover only 3% of the global land area, the peatlands contain more than 500 gigaton of carbon in their peat. That is an enormous amount, but we cannot imagine how much it is. I always say I do not have a gigaton at home. I do not know how it looks like. You can only address that by comparison. But this 500 gigaton of carbon is twice the carbon stock of the world's total forest biomass. So you must imagine 3% of the world that is covered with peatlands has double as much carbon than all the biomass of all the forests in the world that cover 30% of the land. So that illustrates how enormous dense the content of carbon is in peatlands. Peat is like ajak campur or like gherkins. When you remove the conserving water, the organic matter rots away. When you take it out and you put it on the plate and you leave it there for a few days, the organic matter is rotten away. It is no longer conserved by the little acid water. And in the same way, peatlands function. We have done a lot of research in this problem, and it is very clear when the water table drops, the deeper the water table becomes, the more greenhouse gas emissions you have. In Europe, this relationship is when you are below zero. On the x-axis, you see the water table, the mean annual water table with 0. And if you go lower, you see that the emissions increase. And the rule of thumb in Europe is very simple. Every 10 centimeters of lower water level leads to 5 tons of CO2 equivalent more emissions per hectare per year. In the tropics, like in Indonesia, this is even more. There, every 10 centimeters leads to 9 tons of CO2 emissions per hectare per year extra. So that you can use as a rule of thumb how to estimate emissions from peatlands. We have, for example, in Germany, a lot of peatlands drained for grassland where cows are grazing on it. And these grasslands, they emit 29 tons of CO2 equivalent per hectare per year. Again, that is a number you cannot imagine, but it is equivalent to driving 145,000 kilometers with a middle-class car. So every hectare of drained grassland emits per hectare per year the same as that you drive with your car 3-4 times around the earth. The food that comes out of it has an enormous footprint. 1 kilogram of Gouda cheese from the Netherlands contains 55 kilograms of CO2, and 1 liter of milk has the same CO2 content as 2.4 liters of petrol. Imagine you drink a half a liter of milk. It is similar as drinking more than a liter of petrol. That is illustrative of the carbon density of peatlands and how much carbon dioxide can be released by draining peatlands. Oil palm on peat emits something like 60 tons CO2 equivalent per hectare per year. That is the same every hectare every year as that you fly 50 times from Berlin to Jakarta, vice versa, in economy class. So these emissions are enormous from drained peatlands. Globally, the drained peatlands all over the world emit something like 2 gigaton of CO2 equivalents per year. And that means that 0.4% of the land that consists of drained peatlands produces 5% of all global emissions. These emissions occur because of microbial oxidation when the peatland is drained, and of course also by catastrophic peat fires. The peat fires get a lot of attention, but actually from an emission point of view, microbial oxidation is more important with respect to volume of emissions, because this microbial oxidation occurs always and everywhere, and peat fires only incidental sometimes. We all know that Indonesia leads the list of global top emitters. No country emits so much greenhouse gases from peat as Indonesia. But what is often forgotten, the European Union is a good second. The European Union likes to blame Indonesia for its emissions, but we see that the European Union does much less than Indonesia for fighting these emissions. And this is an important political issue, I think. It is worldwide agriculture that is the main cause of peatland drainage. Of all peatlands that have been drained, something like 50% are drained for agriculture, something like 30% for forestry, something like 10% for peat extraction, and then 10% all kinds of small things. Agriculture is the main cause of peatland drainage. And this leads then to big problems. In hot continental regions, peatland drainage, they really create deserts. This is a picture I made in Ukraine, where you see nothing is growing anymore except for very close near the water. All the capillarity of the soil has gone because the soil looks like this. It looks as it is made of stone, without capillarity, and the plants do not get water anymore. We see the same in Kalimantan, in Borneo. Here, a picture I made in Sabah, where you see how the peat has dried so much that it is dust that cannot be re-wetted and blows away like dust, filling up the ditches. A second major problem of peatland drainage is subsidence, a loss of height. This is a process that is already known for hundreds of years, also from Indonesia. At least for more than 130 years, it is known that it is happening in Indonesia. In Europe, they have measured it. They have put poles a long time ago. Here to the left, you see a pole that was put in 1836, and there the height loss has been 3 meters. Right, there is a pole that was put in 1870 in the UK, where 4 meters loss of height has taken place. In the tropics, this subsidence, this lowering of the surface of the land goes 3 to 5 times faster, as is illustrated in this picture on the left. I myself come from the Netherlands that has been draining peatlands for 1,000 years. And in the Netherlands, subsidence is only 1 centimeter a year. But we have in the Netherlands large areas, these red areas, where we have had more than 8 meters of subsidence. That is the way how you change a country from laying above the sea level to a country below the sea level. The Netherlands is famous because people live there below the level of the sea. They made this situation themselves because of drainage of peatlands. And this leads in the Netherlands to huge problems, similarly to Jakarta, for example. There, the streets and the sewage systems go down. The houses are built on poles, they cannot go down. And what we see here is that you have to make new stairways for the children to be able to get into the door because the street is going down. An annual damage of 300 million euros every year in the Netherlands as a result of peat subsidence. So we sit with a situation that whereas the global sea level is rising, we bog the peatlands down. So we are going to cross the line where the sea is going to invade the land again. This is happening everywhere in the world. Here is a picture from the newspaper from Florida in the USA. This is all a big subtropical peatland where you get a loss of height of 3 centimeters per year. And then a big hurricane comes and flooded everything, and they say it is the hurricane. No, it is human stupidity that they have drained the peatland for agriculture, and as a result, the surface is going down, and you invite the sea from coming in. Also in Southeast Asia, most peatlands are coastal, and they will, with continuous drainage, be flooded in future. That is an enormous big problem that is not sufficiently recognized. We have calculated that peatland subsidence will in this century, the 21st century, lead to the uncontrolled flooding of 10 to 20 million hectares of productive land worldwide. And that is frightening. We are losing land now that we need it most, for more people, for less poverty, and for replacing fossil resources. We have decided that until 2050, we have to replace everything that is made of oil. All plastics, all building material made of oil, etc., by renewable resources. We need the land for that. Our root problem is that conventional Western agriculture started in the Middle East, in a semi-desert. And this brought the idea that productive land must be dry. So almost everywhere in the world, except for the places where they cultivate rice, people drain land to make it agriculturally productive. And they also think that the soils have to be moved continuously. And these illusions we apply worldwide on wet organic soils, although this is the best thing to destroy these soils. So, for example, in Indonesia, we cultivate desert plants on drained peat. Aloe vera is a plant coming from the desert, and you plant them in extremely deeply drained peatlands. We do the same in Europe on a large scale. We cultivate semi-arid maize from Mexico on deeply drained peat in Europe. So we know that rewetting drained peatlands solves most of the problems, the greenhouse gas emissions, the fires, the subsidence, and it creates a lot of additional ecosystem services. But we also know we cannot flood all drained peatlands worldwide and take them out of production. We have drained tens of millions of hectares of peatlands for making them productive, for creating something that people can use. So we cannot rewet them all and take them out of production. We have to solve the problems while maintaining productivity. And that is actually where this concept of paludiculture comes in. Paludiculture is a agriculture on wet and re-wetted peatlands and also forestry in a way that emissions are minimized and subsidence is stopped. So it is a wet agriculture and forestry. It is to some extent similar to traditional ways of dealing with peatlands, but we have to innovate these concepts to the modern time. This is, by the way, Pak Havas. He's the ambassador of Indonesia in Germany, visiting us on our paludiculture sites, because he says paludiculture is also a concept that is very useful for Indonesia. So Indonesia needs paludiculture for its huge peatland rewetting program. Here the example of Jelutung, the rubber tree that grows very well under very wet conditions, so that you can re-wet peatlands while at the same time maintaining or recreating productivity. In the tropics, the restoration of peatlands and paludiculture both, they require not only re-wetting, and with re-wetting I mean really wet, moist is not enough, but also reforestation. These tropical peatlands, they have something special. And there the forest plays an important role, an essential role in the hydrological self-regulation. Here you see this picture where in the tropical peat swamp forest, during the wet mousson, water is stored over the surface between the hummocks of the trees, between the buttresses of the trees, between the aerial roots of the trees, that all prevent the water from flowing over the surface, so that there is water in the dry season to feed and maintain the peat. Without forest cover, that back wet mousson, you cannot maintain a peatland in the tropics. So in Indonesia, paludiculture must therefore focus on tree species and on timber forestry products from peat swamp forests, including again Jelutung, here a plantation in Jambi. Or something that can grow under very wet conditions that has been applied in Indonesia already for a very long sago. But there are hundreds of species with good commercial value that come from the peat swamp forest, from natural peat swamp forest, that you can cultivate, where you can have product, livelihood and income while keeping peat body intact. So the problems are actually largely known, and the solutions to some extent also. Important is the implementation worldwide. We have to see it is not to solve these problems, but also, for example, Germany, where I'm working. Indonesia has over the last decades followed the old example of urine draining peatlands on a very large scale. And that has, because the processes in the tropics go very much faster than in the temperate or boreal zone, leads to these enormous problems that we face nowadays, including the enormous peat fires like the last very big ones. We had them, of course, every year, and last year also had the ones of 2015, who were actually a game changer in Indonesia, and I think also worldwide. Since that time, Indonesia has done a lot. I admire Indonesia very much for what it has done. In the period 2017-2019, Indonesia has rewetted maybe 8,000 square kilometers of peatlands. That is 4 times more as entire Europe has rewetted in its entire history. So Indonesia is an important example for it's not enough. Of course, you can criticize that they have not made it wet enough and not good enough. It is a learning process that has to be evaluated, but they give an example that has no equivalent anywhere in the world. I'm also involved in the second largest peatland rewetting project And that is in Russia, where over the last years we have rewetted 65,000 hectares. So only a fraction of what Indonesia is doing. So how must we deal with these cryptic, delicate, diverse, but also explosive peatlands? Peatlands have so much carbon, they are so flammable, that you have to deal with them like with a mine, like with an explosive. And you have to be very careful with that, how to do that. Of course, we have to increase awareness about the character and the presence of peatlands in priority regions. There are a lot of areas where people, most areas of the world actually, where people are not aware of peatlands. So in regions, but also worldwide. And for that purpose, we have founded the Global Peatland Initiative here meeting in Rio 2 years ago. We have to do further research. And in this respect, of course, the initiative of coming to a new international tropical peatland center, it is not developing very fast yet, but it is necessary. We have to exchange the knowledge that has been gained in Indonesia with the Congos, where the processes are started, with involvement of the global north, because they have been draining peatlands for hundreds of years, and they have learned a lot of their stupidities. So we have to bring that together to exchange ideas and to aimfully doing further research. We have to map the distribution and the condition of, in many areas we know that there are peatlands. We are working, for example, at the moment in the Nile Basin, and we expect and we suspect that in South Sudan there are big peatlands, but we do not know it. And this has to be done worldwide with modern remote sensing and modeling technologies like Indonesia is doing, but also with the inevitable field work. We have to go into the field to core, because we cannot see peat with satellite. And we have to that is specifically in Brazil, because that is in New Guinea, in Southeast Asia. This is the Congos in Africa. This is Western Amazonia in South America. There is where the changes are threatening, where we have to stop the destruction of the peatlands. For that purpose, the Brazzaville Declaration was made, and Ibu Siti has played a very good role of exchanging the experiences and ideas and expertise of Indonesia with new coming peatland countries like both Congos here, both the ministers of Congo Brazzaville and Congo Kinshasa, with the world, to prevent that things are happening that are wrong, that we have learned. We should stop these things. We have to re-wet. All drained peatlands must be made wet again. And we have to change the land use from drained land use to wet land use, to polycultures. And these still have to be developed also in Germany. We do not know how to do it exactly. We have only learned how to cultivate under dry conditions, but not sufficiently yet under wet conditions. But all the experiments show that it is possible. So in this respect, it is very good that also Indonesia has created a platform, Polyculture, that we think together of how proceeding with this promising way of dealing sustainably with peatlands. Up till now, because it's a very urgent problem, the focus has been on fire extinction, and that is of course very important, but it is not enough. We must proceed with effective rewetting. Indonesia is the example for the world what to do, but it is not yet doing enough. We have different problems, fire and haze, emissions, subsidence, who work on different damages, who have their importance on different geographical scales, but who have similar solutions. And the ultimate solution of all these problems is full rewetting, not making the things moist, but making the things wet. So the message is clear: keep wet peatlands wet. make drained peatlands wet again, and if you use them wet. Use them in polludiculture. There will be no Paris Agreement without peatlands. Peatlands must be wet for the climate, for the land, for the people, forever. Thank you.
Ya.
Pak Nugroho. Halo Pak Nugroho. Belum di mute Pak.
Okay.
Unmute Pak.
Yeah. Thank you. Thank you, Prof. Hans Joosten. I think we all agree that we got very comprehensive information as an introduction from this session. It's look like introduction anyway. But we also got the testimony from Prof. Hans Joosten that we have restored almost 4 times of Europe from 2017 to 2019. So only 2 years we got huge of peatland restoration in Indonesia. Anyway, we can continue our presentation. Kita lanjutkan saja presentasinya, sementara ditahan dulu Ibu dan Bapak sekalian. Kami akan mempersilahkan Pak Dr. Haris Gunawan untuk bisa menyampaikan materinya. Dipersilahkan Pak Haris.
Terima kasih Pak Nuk. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Good morning, Professor Joosten from Germany. Bapak Ibu, kesempatan yang baik ini kami pastinya sangat mengucapkan terima kasih atas partisipasinya, dan saya akan menyampaikan beberapa poin sebagai barangkali tambahan perspektif, dan saya akan menggunakan kesempatan ini dalam komunikasi bahasa Indonesia. Professor Joosten, I just introduced, I want to use bahasa Indonesia for my presentation, but I also say that very a lot of thank you for you join with us, and hope these opportunities we can brainstorming for how can we more get extend collaboration, and then of course to achieve the real target for the of course decreasing the fire risk, and then of course for the promote wise use of the peatland ecosystem. And then for these opportunities, we would like talk about special in Indonesia peatland ecosystem. So please allow me to use bahasa Indonesia. Okay, let's start. Ya, sudah? Ya. Halaman depannya.
Silamat Pak.
Ya. Baik, saya akan memberikan satu pengantar diskusi buat kita semuanya. Saya beri judul Discovering Knowledge to Restore Tropical Peat Ecosystem Landscape. Jadi pastinya tidak akan lengkap pengetahuan yang sudah ada dan juga ongoing sedang dikerjakan oleh para mitra riset kita, tetapi dalam kesempatan ini saya pastinya ingin menyampaikan beberapa update terkait dengan hal tersebut. Ya, baik. Bapak Ibu yang kami hormati, kita sudah sangat memahami dan mengenal sangat dekat dengan problem ekosistem gambut di Indonesia yang tadi sudah juga diberikan pengantar oleh Profesor Joosten. Tetapi dalam kesempatan ini kita juga mendapat apresiasi yang luar biasa terhadap terobosan kebijakan konstitusional untuk bagaimana kita bisa melakukan upaya-upaya solusi komprehensif dan permanen dalam konteks bagaimana kita mengelola dan memulihkan ekosistem gambut di Indonesia. Dan ini perlu dukungan pengetahuan yang pasti menantang kita bersama bagaimana kita bisa terus melakukan upaya-upaya riset dan pengembangan juga inovasinya. Baik, Bapak Ibu yang kami hormati, Badan Restorasi Gambut ini diberi mandat dengan kata kunci percepatan pemulihan kawasan dan pengembalian fungsi hidrologis ekosistem gambut secara sistematis, dan juga ini menyangkut kepada upaya-upaya yang melibatkan banyak pihak, karena kita sudah ketahui bersama kegiatan restorasi gambut perlu kerjasama dan sinergi kepada para pihak. Dan di Badan Restorasi Gambut ada satu kedeputian riset dan pengembangan untuk bisa melakukan secara terus-menerus melakukan apa yang kita sebut sebagai discovering knowledge and innovation. Jadi bagaimana kita terus mengembangkan pengetahuan dan juga inovasi dan menemukan terobosan-terobosan yang memungkinkan untuk kita bisa melakukan apa yang dimandatkan oleh Presiden terkait dengan percepatan pemulihan kawasan dan fungsi hidrologi dalam ekosistem gambut. BRG mendapat mandat sekitar 2,4 juta hektar di 7 provinsi, dari total 12,9, ini hampir 20%, yang terbagi menjadi sekitar 106 blok-blok ataupun kita sebut sebagai kawasan hidrologis gambut atau pit hydrological units. Dan untuk membantu bagaimana atau mendorong bagaimana potensi yang luar biasa ini bisa dibaca dan dieksplorasi dengan data-data dan analisis saintifik, kita perlu kerjasama dengan lembaga-lembaga riset dan juga universitas. Dalam hampir kerja 4 tahunan lebih ini, kami menggandeng teman-teman riset, institution lain di Indonesia, hampir 31 riset partner, dan kita sudah melakukan kegiatan hampir 120 riset package. Dan yang lebih penting juga kami ingin menyampaikan bahwasannya terkait dengan apa yang tadi disampaikan Profesor Joosten, beliau menyebut bagaimana gambut itu harus dibasahkan, harus basah. Jadi bukan hanya moist, tetapi juga harus berbasis kepada karakteristik alaminya atau karakteristik dasarnya dari ekosistem ini adalah air. Untuk itu, Badan Restorasi Gambut melalui Kedeputian Penelitian Pengembangan terus mengembangkan satu monitoring yang kita mendapat dukungan dari teman-teman di BPPT dan di universitas dari mitra kita. Ada 154 real time alat yang kita bisa pantau bagaimana kondisi hidrologi di kawasan-kawasan gambut di lokasi-lokasi target prioritas restorasi gambut. Bapak Ibu, kami ingin juga menyampaikan dalam kesempatan yang baik ini, Presiden Jokowi sudah betul-betul memberikan pesan yang sangat terang benderang bagaimana seharusnya kita bisa melakukan mitigasi, melakukan upaya pencegahan terjadinya resiko kebakaran. Beliau sampai menyebut berkali-kali tentang air, tentang gambut basah, tentang bagaimana kegiatan restorasi itu dilakukan secara terus-menerus dan konsisten. Biarkan gambut itu, air itu ada di gambut. Dan ini terus kami diskusikan dengan mitra-mitra kita Dan salah satunya yang sekarang juga sedang dikerjakan adalah dengan pendekatan ekosistem dari kementerian dan lembaga, bagaimana juga melibatkan upaya yang sangat dini, bagaimana memanfaatkan teknologi modifikasi cuaca untuk membantu upaya membasahkan gambut. Ini barangkali menerjemahkan bagaimana arahan dan juga perintah Presiden terkait bagaimana ekosistem gambut di Indonesia itu tidak boleh lepas dari faktor dasarnya adalah aspek hidrologi ataupun aspek air. Untuk itu, Bapak Ibu, next. Kami dari riset dan development di Badan Restorasi Gambut coba memetakan sebenarnya apa yang sedang berkembang, riset-riset apa yang sedang atau sudah dilakukan di dunia terkait dengan tropical peatland ekosistem. Ini memang masih ada luar biasa challenge-nya, karena dari hasil pemetaan dan katakan juga identifikasi kami, ternyata memang riset-riset yang terkait dengan hidrologi, terkait dengan bagaimana membuat gambut itu basah, mengelola gambut itu basah, bagaimana gambut basah itu bisa juga menopang ekonomi yang berkelanjutan, itu memang masih sangat minim. Jadi kalau Bapak Ibu bisa lihat ini klaster-klaster yang paling banyak muncul di paper-paper yang sudah di per-review atau yang sudah terpublikasi di jurnal-jurnal yang ada di dunia ini, banyak sekali pada 3 klaster besar. Adalah klaster emisi, klaster kemudian distribusi organic matter dan lain-lain, juga klaster degradasi dan deforestasi setelah fire. Ini hanya sedikit sekali, sangat kecil sekali ada publikasi terkait dengan hidrologi, terkait dengan bagaimana kita bisa melakukan pengelolaan ekosistem gambut berbasis hidrologi, berbasis neraca air, berbasis water balance. Ini sangat-sangat minim. Untuk itu, ini mengundang kita semua, menggelitik kita semua, bagaimana kita bisa membuat klaster yang sangat mainstreaming, bagaimana ekosistem gambut ini didukung oleh scientific base tentang riset-riset robust terkait dengan bagaimana kita membasahkan gambut. Atau kalau ini Profesor Joosten bilang, selalu menyampaikan istilah pit must wet, atau bahasa Jermannya Nash. Bapak Ibu, slide ini memberikan kepada kita semua challenge besar, terutama karena ini Pak Nugroho dan tim mengkondisikan kegiatan diskusi terfokus ilmiah. Ini menggambarkan challenge bagi kita semua, komunitas akademik, komunitas peneliti di Indonesia, di dunia, untuk bisa membuat klaster yang lebih cepat. Bagaimana penelitian-penelitian hidrologi interdisipliner yang langsung terkait dengan aspek hidrologi ini menjadi sangat-sangat harus kita kerjakan dengan segera, karena jelas-jelas menindaklanjuti arahan dan perintah Presiden bagaimana ekosistem gambut harus ada air dan terus-menerus diperbaiki sistem tata air di lahan gambut, terutama di Indonesia. Bapak Ibu, ketika kita bicara ekosistem gambut, ini ada satu slide yang memberikan contoh. Sebenarnya kalau kita mau bilang ultimate goal terhadap restorasi gambut, ini apa yang kita bisa lihat ada di depan 2 slide ini. Tetapi sekali lagi, ini tidak gampang kita temukan di lapangan dan tidak banyak data-data dan informasi serta analisis yang robust bagaimana kita bisa mencapai ini. Apalagi dalam landscape scale. Ini menjadi PR-PR penting bagaimana kita harus melakukan upaya-upaya yang sistematis dan percepatan terkait dengan riset-riset bagaimana kita mengelola ekosistem gambut berbasis air dan ini perlu kalkulasi yang sangat-sangat precise terhadap berbagai macam aspek terkait dengan hidrologi. Bapak Ibu, Badan Restorasi Gambut dalam konteks untuk melakukan menjawab terhadap problem-problem tersebut, kami mengembangkan sistem pemantauan alat di lapangan sekitar 154, meskipun ini masih on progress, tetapi kami ingin menggunakan seoptimal mungkin, Bapak Ibu, data-data tinggi muka air di lapangan yang sudah tersebar di 7 provinsi untuk kami lakukan spasial ekstrapolasi dan analisis, sehingga kita punya data dan punya informasi yang sangat-sangat kita harapkan bisa menggambarkan ekosistem gambut berbasis landscape yang ada di Indonesia. Dan ini suatu kebutuhan bagaimana kita terus menggunakan data-data dasar, data-data ground yang seperti disampaikan Profesor Joosten tadi. Kita perlu terus melakukan ground checking, ground truthing, melakukan eksperimen-eksperimen di tapak, di lapangan, karena satelit analisis, remote sensing itu bagian dari tools untuk membantu kita menganalisis, membuat modeling yang lebih luas dalam skala landscape. Untuk itu, kami terus mengembangkan kerjasama dengan berbagai mitra, dan paling terobosan yang sekarang sedang kami juga lakukan adalah membuat satu FDRS khusus gambut berbasis data-data air di darat dan kelembapan tanah menggunakan analisis citra satelit dan remote sensing. Bapak Ibu yang kami hormati, ini contoh kecil yang kami sudah lakukan dalam kerja-kerja Badan Restorasi Gambut terkait dengan rewetting di salah satu KHG di Pulau Rupat di Kabupaten Bengkalis, Provinsi Riau. Bapak Ibu bisa melihat bagaimana intervensi pembahasan gambut itu sudah menunjukkan tren ada reducing the fire risiko kebakaran. Itu Bapak Ibu bisa lihat dari monitoring kami. Ternyata kegiatan-kegiatan EPG itu mampu melakukan upaya-upaya mereduksi resiko kebakaran. Tetapi sekali lagi kita perlu melakukan upaya yang lebih banyak lagi, lebih sistematis lagi, dan lebih skalanya lebih dalam rentang landscape. Ini pembelajaran menarik bagaimana kita sebenarnya solusi permanen ataupun solusi hulu terkait dengan musibah ataupun kejadian kebakaran lahan gambut dan bencana asap harus kita dekati secara komprehensif. Salah satunya adalah restorasi jawabannya. Lanjut. Bapak Ibu, satu contoh lagi yang memang perlu menjadi challenge bagi kita bersama, merestorasi tidak bisa hanya dalam satu lokasi, satu site, satu titik. Ini harus berbicara pada landscape scale. Kami contohkan dari 106 landscape peatland, salah satu yang kami punya cukup data dan informasi ada di landscape yang kita sebut tebing tinggi, landscape KHG tebing tinggi di Kabupaten Prioritas Restorasi Gambut adalah di Meranti, Provinsi Riau. Bapak Ibu, ini adalah gambut kepulauan yang sangat unik. Sumber-sumber air satu-satunya hanya dari air hujan. Tetapi kenyataan existingnya kita bisa lihat di sana ada kegiatan perambahan, illegal logging, juga ada pengembangan kota di sudut di Selat Panjang, dan juga ada kebakaran yang di tanda merah tersebut. Tetapi di landscape ini juga ada monumen ekologi yang luar biasa yang hampir hanya dijumpai di landscape tertentu, terutama masih tersisa di Riau, adalah apa yang kita sebut sebagai kubah tasik atau danau di atas kubah. Ini menjadi heritage, world heritage, bagaimana ekosistem gambut di tropis sangat unik. Dan kita terus mengerjakan analisis untuk melakukan upaya-upaya bagaimana ini bermanfaat untuk pengembangan pengetahuan terkait dengan pengelolaan ekosistem gambut. Bapak Ibu yang kami hormati, kita ketika kita bicara terkait dengan landscape scale restoration atau restorasi di skala KHG, kita tidak bisa berdiri sendiri. Pengembangan potensi yang ada ini harus terintegrated. Kami sebut sebagai istilahnya adalah 3R dan Bayan 3Rs di satu peatland hydrological unit. Dan kami mengembangkan riset Bayan commodity and Bayan sustainability, apa yang kami sebut sebagai payment for ecosystem services. Saya pikir ini menjadi penting ketika gambut dapat kita dorong, dapat kita kelola dengan baik, maka kita akan mendapatkan satu benefit-benefit selain payment ekosistem, selain jasa-jasa lingkungan, tapi juga kegiatan ekonomi yang lebih ramah terhadap ekosistem gambut. Next. Bapak Ibu, saya pikir dari apa yang saya sampaikan tadi, kami memberikan mungkin bukan sebuah kesimpulan, tapi setidaknya catatan bagaimana gambut ini memang perlu ada riset yang benar-benar harus dikejar oleh waktu terkait dengan aspek hidrologi. Gambut harus basah dan juga bagaimana kita mempertimbangkan kebutuhan air, water balance untuk berbagai macam kepentingan yang sudah mengalami keterlanjuran di berbagai macam landscape atau di berbagai macam KHG. Dan kita perlu melakukan melakukan tindakan-tindakan yang benar-benar precise. Bagaimana rewetting ini bisa berjalan dengan baik. Untuk itu, research how to conduct restoration on landscape scale is also big task to be solved. Baik, Bapak Ibu, we must use all available modality, data, activities, and networking for achieving Bayan sustainable tropical peatland landscape management, and how we can generate positive impact for communities from our effort in restoring the tropical peatland landscape. Saya pikir itu Bapak Ibu sebagai pengantar yang bisa kami sampaikan. Tentunya kami mengharapkan masukan, pemikiran, dan juga gagasan bagaimana kita bisa meneruskan upaya-upaya pemulihan gambut, pengelolaan gambut, perlindungan ekosistem gambut yang tadi sudah disampaikan oleh Profesor Joosten, bagaimana the importance of ekosistem baik di tropis maupun di boreal. Saya pikir demikian Bapak Ibu, lebih kurangnya mohon maaf. Assalamualaikum warahmatullahi wabarakatuh. Kembali ke Pak Nugroho.
Ya, terima kasih Pak Deputi, Pak Aris Gunawan. Beberapa poin bisa kita angkat dari apa yang telah Bapak sampaikan. Tapi kita keep dulu, paling tidak kita mungkin nanti perlu elaborasi bagaimana scientific approach ini bisa kita utilize lebih dalam lagi untuk kita pakai dalam policy restorasi gambut di Indonesia ini. Selain tadi sudah beberapa hal yang sudah diangkat dari Pak Haris. Untuk selanjutnya saya ingin mempersilahkan Prof. Azwar Maas untuk menyampaikan materinya. Dipersilahkan Prof. Maas.
Tolong di-share-kan paparan saya, sudah saya kirim. Bapak-bapak dan Ibu sekalian, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. And for Pak Joosten, good morning. And nice to see you again, yeah. And yeah. Halo, siapa itu? Okay, yeah, we just talk about the tropical peatland, and then for me, this is a long story that I know. There are some differences between European peatland and our peatland, especially in this lowland area. Ya, terus, please, next slide, please. Ya, So our pit is consists of remnant of the woody material that fall down to the swamp, and the greening one is already fastly decay and liberates CO2 and other nutrients and easily move away. Yeah. So our pit is residual of the wood remnant, poor in nutrient because the nutrient is pass away, go away, by leaching. And as we know that we have plenty of acidic coming from the organic acid. Yeah. So we have different pit land, mostly in the lowland area. We call that lebak, that not affected by tidal movement. And then pit with no kubah, or what we call that unbroken pit, and topogen pit, and other one is with berkubah or unbroken pit. Yeah. Next slide. So here one picture showing us the natural condition of the peatland. The nutrient has been cycled from one decayed trees to the other young one. So the nutrient not moving away. Yeah, the nutrient is based on the upper part of the surface of the pit, what we call that Selasa. Yeah. Selasa decay and then liberate nutrient, and this nutrient will be used for other plant. So in how we can create this pit, because the nutrient is cycling and the water not move fastly, and you see also in the top of the left side, you see the water that in between the peatland is yellowish, and gives this water during the spillway of the high tide will give you nutrient and also clay. Yeah. So if we say that topogeneous pit, so it means the ash content will be higher than the ambrogenous pit. Yeah. This is what we see, more thick pit and then less plant in the good shape. Next slide, please. Next slide. So this is just illustration. Yeah, the first planting in the shallow sediment in the swamp is greenish because the nutrient is higher. The plant's root going down to the muddy material, and then later on this plant decay and then start to have pit, and by the time become poor and poor because the last plant is almost grow on the former decay of the plant. You see here in the top of the dome in Pengelolaan, the original plant, this is primary forest, just very thin. Yeah, the diameter of the wood is only about less than 15 or 10 centimeter. And above this thing, what the Pak Haris said, that we have format what we call tasik, because so poor, there is no more good plant or wood can grow over there. Just on the surface of that tasik, just a seed with can moving. Yeah. Just continue. The next slide. So this is we believe in the mineral soil we have secondary mineral soil, what we call clay, but in the residual woody there is no secondary material. So it means formation of mature pit or from the fibrous hemis and apris, just the small become small the size, because that's not possible to form secondary organic pit, for example. Yeah, so that's much different to your European or the pit that become from the plant grow in the water. Yeah, this is we have also this kind of pit in the Dieng area. Yeah, very soft, easy to cut, and also fertile. We have so completely different with your type of pit. Terus, next slide. I think this is in natural condition, and what if the pit will be converted, and then there is some changing on it, and then you, Prof. Jensen, already mentioned to us, but I just want to show you so important conservation of the peatland in natural condition. Yeah, how to the future we should going back, retreat back, and then how far that we can do it. Terus, next slide. This is the formation of how the pit is formed that I mentioned before. Yeah, that's not so important. This is quite old references. Yeah, continue. So that we start on, let's say, before 2000 actually, yeah? And then during that moment, 1997, we already mentioned about the what we call that satuan hidrologis gambut, yeah, and that during the let's say what that one Waklimat, yeah, we agreed to have this KHG, and then later on this concept of the hydrological unit has been used in our legal aspect on the PP government regulation on 71 and 57. Yeah, Bruce. Next slide. This is the explanation of one of the PP 71 and on the 2014. Yeah, yeah. I think utilization function and the conservation function based on the naturally it should be done for the homogeneous fit. Yeah, because they have a kubah. Yeah. So 30% at least based on the calculation of water balance actually. Yeah, terus next slide. Yeah, during the RAPIM, what we call that meeting sector with heading by President on 2017 is already 9 conditions should be done. Yeah. All of them is how to reduce the fire. Yeah. And then how the pit can be moist at least. Yeah. And can be saturated, can be wet. Yeah. And I believe that the quality of water also will be a good parameter to be used. If the water is still moving, even in the shallow groundwater. So enough oxygen in the water, and then the root can be make his respiration. So they're able to attack the nutrient and water. But if the water is stagnation water, and then the redox potential is going down, and then no more root respiration, and then the plant will not able to grow anymore. Yeah. So groundwater should be also checked if the groundwater is stagnation or can still moving. So that is why our concept on the 30% of the top of the pit should be a storage of water, and then the water will slowly move to the whole KHG. Terus next slide. Bahasa Inggris saya cukup bisa dimengerti toh, Bapak dan Ibu. Nanti saya nyotot sendiri, bahasa Inggris saya jelek juga, ya. So here how we calculate the water balance, yeah. How much the conservation should be done, and then if we conserve, for example, 30%, if there are no rainwater, how long this water can go down, distributed to the whole KHG. If, for example, our evapotranspiration daily is 5 millimeter. So we think that we should give a point. If there is no water inflow within, let's say, 2 months or 60 days, so we will have problem. If we conserve 30% as a source of the water, that will not able to distribute anymore with more than 60 days. We should enlarge 30 centimeter, for example, 50%. So it means if we conserve 50% of the top of the dome pit, we may be able to extend our water moving down up to 3 months. This is one thing that we should consider, because in the regulation said at least 30% of the top of the dome should be conserved as water resource during dry season. Terus, next slide. Here also interesting, yeah. That's not possible to have pit formation in the sea. So the pit, let's say, separate from the stride normally. Yeah, it happened about 5,000 to 4,000 years ago. Yeah. If we have rock, if we have inundation, abrasion in the mineral soil, the abrasion of, for example, clay material will lay down on the below the canal. But you see here 2 glass, yeah, I mentioned, I give example. If we sack the pit with seawater, so most of the pit will be dispersed, yeah, because strong molarity. The seawater is about 0.7 molar, and the pH is more than 6, and the pH less than 3. Yeah, so this water, seawater, able to disperse. Yeah, that's why I said don't use lime to the pit, because lime also able to disperse the pit. Next slide, please. This is some example where we use water balance on each sub KHG, because one KHG will can be distributed to more sub KHG, and we have one dissertation out of this research, and this research will has funded by Deputi 4 of BLG, and I was a supervisor for these guys. Yeah, he got British distinction. I think I forgot about that. But he was done it for about 4.5 years to finish his study. Terus next slide. Yeah, this is our regulation mentioned about how we should do in conservation function, and then what we can able to use the plantation function. Yeah, this is well known, and then most of us understand about that. I'll continue. The problem is how to get that value. Yeah, so that's why we said we should have restoration. Yeah, bring back the function of conservation, and based on the calculation of water balance. Yeah, and how, and that conservation area, no more canal. We should fulfill the canal fully, and even I think also the natural canal, yeah, also should be closed, yeah, because we should have a completely optimize the water resource, especially to be used in the dry season, yeah. And in the utilization zone, yeah, we should have a good blocking canal system with able to keep the groundwater table about 0.4 meter. This value, yeah, also important not to let the surface of the land is bare. Yeah, my experience said that if even the groundwater is close to the surface, but in the surface area is bare, the water can infiltrate to the surface, but the surface go directly as evaporation. So don't let the surface in open bare, but the surface of the pit should be at least have cover crop. Yeah. If you walk with in the pinggir-pinggir kanal, ya, dan di sana ada pit, jalan kendaraan, maka selalu saja berdebu. Ini adalah indikasi karena dia terekspos ke udara, dan kenaikan kepiler itu sampai ke dekat permukaan akan langsung mengalami penguapan. Jadi in the planting area should be have crop cover, better with legume crop cover. Terus next slide. This is the example of bare land. Even you see the groundwater is close, but the bare land, the pit easily become hydrophobic and easily will be burned. Yeah, if somebody give fire on it. Let's continue. This is our formal PLG, and then you see also even in nature condition, after let's say 7 years, then in nature condition, the erosion or runoff of the top bare peatland is closed and moved to the canal. Yeah. Just continue the other slide, please. Yeah, this is in activity of PUPR or Dirjen Sumber Daya Air, yeah, PUPR. How they try to avoid more runoff, and then they make the dam close to the river, and then the result is the pit become wet, and then this wet pit also reflect in the greenish plant around it. Next, please. Ya, selanjutnya. Nah, ini adalah bangunan-bangunan yang dikerjakan oleh PU, dan ini memang kalau ini adalah bangunan yang heavy, that should be in the mineral soil. Not possible to create this system in the pit, especially for the depth thick pit. Yeah, this value only can be made in the alluvial in the leafy of the one KHG. Yes, continue. So how the way we should apply the water balance? We should have good data on, for example, thickness of the pit and LiDAR, for example, and then in some part we have already complete on it, but how to use it to be later on submit for the decision of the zonation of the conservation and utilization. That should be decided by Ministry of Environment and Forestry, for example. But until now, we don't have yet that point. Yeah, we should go to that direction, and then we should also agree for everybody having living or improving in that KHG. Yeah. Okay, this is that's an example. Yeah. Continue. There is some more slide or just continue. Sudah habis atau masih ada ini? How Pak Nugroho, if you still have to keep me talk, we can still talk, but what time is it? Yeah, this is a
3 menit lagi Pak, supaya
factor trigger for burning, firing, So I agree in the tropical there is more than 90% of the fire is caused by human, and human doing the fire because of combination or one of the factor, you can read on it, Terus because time is running, Pak Nuk, okay.
3 menit lagi Pak,
Let's continue. This is the concept of the how we protect the fire, and we should have also early warning system, and we said that early action for fire protection is better rather than if, let's say, lot area should be rewetting. So I mentioned here, if 1 hectare of fire that we should have 5 centimeters of the water, we need about 500 ton water in 1 hectare. So how can we do it? Not possible. Just rain can do it. 50 millimeter of rain able to terminate the fire. That the water is continuously, not 50 millimeter, for example, in during 3 days. That's also not possible. Okay. Next slide. Yeah, this is the resume, and then you can read that. I think sharing water is important, water balance is important, and then maintenance of the water important, and then blocking canal also important. All these things, agriculture also the most important thing for the life of human inside of the KHG. If the pit become moist or wet. Thank you very much for your attention.
Baik, terima kasih Prof. Maas. sampai dengan sekarang Prof. Emil Salim tidak bisa bergabung bersama kita. Prof. Joosten, until now Prof. Emil Salim is unable to come along in this discussion. So we now come to the next session. I will please to presenter to give additional points after you hear from other presenters. So I will provide not more than 5 minutes for Prof. Joosten, kepada Pak Haris, dan terakhir kepada Prof. Maas supaya beliau bisa ambil nafas dulu, minum-minum dulu. Kira-kira 5 menit. Dipersilahkan Prof. Joosten, you please your turn if you want to have some additional points that need to be raised after you hear from other presenter. Please, Prof. Joosten.
Yeah, I can say something about what I have heard. For example, the important question is how to get water into the drained peatlands. That is the most important question. And I think we can learn there from natural peatlands. Natural peatlands do that by keeping the water in. So most of the peatlands where we are talking about are rainwater-fed peatlands. So you get your water from above. And the problem everywhere in the world is that we let run away this precious water too quickly to the sea. That is actually what we do with drainage. We remove the water of which we think it is superfluous, that we do not need it. But actually we need a lot of this water that falls in the wet season to have sufficient water to feed the entire dome in the dry season. So we have to keep this water in. And that is, of course, has as a consequence, we cannot, it is not sufficient to have your water up to the surface in the wet season. You have to have it over the surface. And that is actually similar also in temperate and boreal peatlands. And there you do not see it, that it is above the surface, but it is actually above the peat because it is in the moss layer. But in tropical peat swamp forests, it is really above the surface, and you see it as open water between the hummocks, between the roots, etc., etc. If you remove this irregularity of the surface and you remove the trees, then the water runs away quickly in the wet season, and you do not have enough anymore for the dry season. So the best way to get water into the peatland is not to run away in the first place. And that is an important, it has of course far-going consequences also what you can do with a peatland. So it also determines what kind of crops and what kind of use you can make out of it. You must have structures that keep the water as long as possible in the wet season. So you cannot make it smooth. You cannot make a crop that needs moist conditions always. You have to have crops that can withstand these very wet conditions, or that are growing on hummocks or in the trees or whatever. So it is very difficult to apply simple conventional crops in a modified way on these peatlands. For example, often pineapple is mentioned. Pineapple can, of course, grow very wet. It can be flooded for a period. But on the long run, it is not wet enough to keep the peatland so wet that the peat is not oxidizing in the dry periods. And yeah, it is, of course, a question of where are you going to? Of course, you can reduce the rate of subsidence. And of course, reducing is better than doing nothing. But I always say, if you are running in the direction of a cliff, of course it is smart to decrease your speed, to lower your speed. But eventually you have to stop and turn around, otherwise you will fall down the cliff. and the situation with a lot of peatlands in Indonesia, actually most of them it is, that if you continue the subsidence, and if you do not stop subsidence, in the end, these areas will be flooded by the sea. That can go quickly, that can take 100 years, but a country that is concerned about its sustainability must be concerned what is happening with its land in 100 years. In 100 years, you will have as many people or even more than you have now that have to be fed and that have to be provided. You have to have income. And you cannot allow your country to lose land. And if you allow subsidence to continue, even when it is slow, you will lose a large part of your land. That is an important issue. The second general remark that I want to make, I hear very often that there are big differences between tropical peatlands and boreal and temperate peatlands. Of course, if you pick one type out in the tropics and one type out in the boreal, there are big differences. But also in the tropics, there is a wide variety of peatland types, and in the temperate zone and in the boreal, there is a wide variety of peatland types. And in general, you can say, okay, when you go to the tropics, like Pak Azwar was also saying, then the more resistant plants like trees and high shrubs, etc. And shrubs are increasing. And also the material that is deposited is more resistant. It is lignin, it is more phenolic, more aromatic, and less cellulosic, etc. But these type of peatlands we also have. We have also forested peatlands here in Europe, alder forest. We have done a lot of research in that. And the peat looks the same. It is also made out of wood. And actually, the tropical peat swamp forests of Southeast Asia are functionally much more related to the peat moss peatlands of the boreal than to the alder peat swamp forests of Europe. So you should not be confused by how these things look like, but how they are functioning. If we want to manage peatlands in a decent way, we have to understand how they are functioning, specifically in a hydrological way, because water is so important. And that should never be forgotten. A peatland is always this triangle of plants and peat and water. These are a unseparable unity. If you change one of them, all the others will also change. The vegetation is necessary to create peat, but it is also specifically in the tropics necessary to maintain the hydrology. And all these connections exist. That's, I think, the most important things I want to say now.
Yeah. Okay, thank you very much, Prof. Hans Joosten. Pak Haris mungkin bisa merangkai dalam suatu KHG. Silakan Pak Haris.
Yeah, thank you Pak Nugroho. I would like to add some, I think, information. As all of you know well about the Indonesia peatland, and of course, we already developed peatland for many purposes, and then peatland also give the many benefit for Indonesian society, and we need to, how can I say, sit together how to change the we call paradigm. If possible, because when we visit to the some area in the village or in the KHG, if we talk about the re-wet peatland or wet peatland, so they do not, how can I say, really understand what the real wet peatland, because you know that they're thinking how to use the peatland by by using the drainage peatland. So we need to, how can I say, the scientists, the scientist society, community should be pushed to all of the stakeholders that this is need to change the culture for all of us, because we just thinking if we want to survive in the peatland. So right now they're thinking about dry peatland. Right now, today, we talk about the wet peatland. We talk about the moist peatland. But in the real, there are big gap about the idea of the scientists with the society. So we need to, I want to just share the possibility to change the paradigm, and then also how to accelerate and then speed up for making, we call the wet civilization, if possible. Because in Indonesia, when I visit to the Netherlands, the scientists say that you restore the peatland that the community already live there. Is it possible? Yeah, it's possible. Why? But this is need time, need process. We cannot directly making wet the peatland in Indonesia. So we need engage the community, the society, and the many stakeholders for understanding what the scientists thinking. That's, I think, Pak Nuk, we need to how can I say media or some meeting and publication with many participants with different background and different idea. I think scientists should be fully involved for changing this paradigm. I think that's all, Pak Nuk.
Ya, terima kasih Pak Deputi, Pak Aris. Selain kita mempertemukan perspektif yang macam-macam ini, kita mungkin perlu berpikir untuk menentukan policy bagaimana bisa ini bertemu. Mungkin sedikit Pak Prof Maas sebelum you want to add something, Prof Hans?
Yes, I want to add a little bit to what Pak Hannes is saying, because he was explaining so nice of his visit to the Netherlands. But the Netherlands is in itself an example how paradigms have changed very much. When the people started to use peatlands in the Netherlands for agriculture, they drained them deeply and they used them for arable agriculture, for cereals. But then subsidence started, and as a result, the water level came up relatively, and they could not cultivate these dry crops anymore, and they started to cultivate wetter crops, grasses. And that is how the cows and the cheese and the milk has come in the Netherlands. That is a change. It is an adaptation of the changing condition of the peatlands. The peatlands were getting after drainage by subsidence too wet, and they changed the entire economy. Now the next step is, because now these grasslands are going down, and these grasslands are laying deep below sea level, so deep that it is really getting dangerous. Now they have to change the paradigm again, and raise the water level and develop new crops for their livelihoods that are compatible with wet conditions. And this process has now started. So that is where it is all about. The necessity of subsidence will force you to develop new economic concepts, new financial concepts. Otherwise, you have to give up this land completely. Thank you.
Yeah, thanks, Prof. Hans Joosten. Very good example for change of paradigm in Netherlands. Oke, Prof. Maas mau menambahkan sedikit, Prof?
Saya mungkin menambahkan sedikit bahwa untuk mengerti mengenai gambut ini kita juga harus mengetahui apa kejadian secara geologi, kemudian secara geomorfologi, dan secara pedologi. Jadi 3 urutan ini penting. Ya. satu hal, misalnya kita tahu itu batu bara. Batu bara itu di mana-mana selalu mengandung asam sulfat, ya. Jadi artinya dia dulunya itu berasal dari gambut yang ada di daerah tropis, yang ada di garis-garis pantai tropis. Dimanapun kita temukan batu bara sekarang itu sebetulnya secara geologi terbentuknya itu pada rawa yang ada gambutnya, ya. Kemudian yang juga ini mungkin banyak yang belum tahu bahwa intan itu adalah karbon tersambung dengan karbon dan dipadatkan, dan dia berasal dari batu bara berasal dari gambut, ya. Jadi ini yang hal lain yang saya di luar dari apa yang kita bicarakan. Terima kasih.
Terima kasih Prof. Maas. Oke, Ibu dan Bapak sekalian, kita masuk ke sesi ketiga. Saya membuka untuk komen, saran, pertanyaan untuk general discussion untuk participants. Ada 3 fasilitas. Saya tetap membuka juga pertanyaan yang kami pilih dari YouTube karena ada sekitar hampir 60 orang di YouTube. Kemudian dari Zoom, bila ada yang mau tampil visual, kami menyediakan raise hand facility. Kemudian dari chat, ya. Chat sudah ada diskusi menarik, tanya jawab dari beberapa partisipan yang dijawab langsung oleh Prof. Hans Joosten. Silahkan menikmati di chat, walaupun masih ada beberapa pertanyaan yang nanti mungkin kami angkat karena belum sempat terjawab oleh Profesor Joosten. Saya ingin mempersilahkan yang di raise hand bila ada. Sambil menunggu yang raise hand, saya justru akan mengangkat yang dari YouTube. Dari YouTube mungkin Pak Haris bisa memberikan jawaban, dan Prof. Joosten juga. What if the use of peatland resources could guarantee availability at the same quantity and quality? Jadi bagaimana gambut ini bisa sebagai sumber daya bisa memberikan garansi ketersediaan sumber daya ini dalam satu quantity and quality. What are the side effect if they hold the use of these resources? Apa efeknya? Jadi ada apa sumber daya yang bisa kita manfaatkan dan apa efeknya? What the resource in peatland that can be utilized and what the effect, Prof. Joosten? Pak Haris dulu barangkali bisa mengelaborasi. Dipersilakan Pak Haris.
Ya, Pak Nugroho, thank you, and then also for the participant giving the question, and I want to respond for the good question. I think as you know that peatland, how can I say, so lot of we call sustainable natural resources. Yeah, unfortunately, in the 2 decades, we do not optimize these resources for our sustainability, this ecosystem. So we try to change the approach for optimize the development of this ecosystem, and not follow the very basic characteristic of this ecosystem. So for the scientists say that this ecosystem should be thinking and consider in the 3 very basic principle. We call the water, and then vegetation, and then carbon. So I think for the future we have to consider everything that we can use or we can develop this ecosystem should be consider these three very basic aspect for this ecosystem. So I think, of course, we need time and we need innovation and, of course, the breakthrough for changing the existing that we already develop on the peatland. But Professor Joosten just mentioned and give us lesson learned. Hopefully, we do not wait for the environment and then just only give warning, not give us to push to change our paradigm. I think we already start that Indonesia right now to start changing the paradigm of utilization peatland ecosystem. I think that's all, Pak Nuk.
Ya, terima kasih Pak. Prof. Joosten, you would like to answer this comment and question,
Yes.
please?
So the question, which resources can replace the present day use, is of course a very good question. I think it is first necessary to widen the scope where we are looking at. So if you look only on a plot, what the economic revenues from this plot are, you get the wrong impression. I think that most use of peatlands in Indonesia and wherever in the world, of course, has an economic revenue on the private level, but on the societal level, it has a damage that is much larger economically than the private profits. So it is not a good system which makes on a large scale more damage than it has revenues on the small scale. That is one thing that we have to keep in mind. The second thing is that we have to not compare the future, what are we going to do with this land, with the present state, and we have to compare the future with what the future would be if we could continue in the way as we are doing now. And if we are continuing in the way we are doing now, we will not be cultivating palm oil or cultivating pulpwood on these peatlands, because these peatlands will be flooded by the sea. That is what you have to compare.
Yeah.
Also, on the long run, it is not a question compare the future with the present, but compare the alternative future with a future that is inherent to a business as usual. And from both perspectives, both the spatial scale as the temporal scale forces you to change the business as usual. And whether that is economic on a small scale, it is not economic at the moment. It is only because we have a limited view on this small scale, but it is not economic. So if we have to solve the problem and we come up with crops that on the small scale have less revenues, but also much less damage, then it is economic smart to do so. And then the only question is, how do you find a financial construct that you pay people for reducing the damage to the world, and how the world is going to pay for that? That is the question, not the thing that you have to change. And very important is also, that is what we meet in Germany and in Europe. We have, for example, important food crops on peat, like potatoes and carrots, etc., etc. And then you say, yeah, but we cannot cultivate food crops in Europe, not yet, on rewetted peatlands. Yes, but then I say, we have millions of hectares of energy crops on mineral soils. We can cultivate easily energy crops on rewetted peatlands. And then your potatoes have to go to the mineral soil. You have to swap the places where you are cultivating what. You should not expect that you are able to cultivate everything on every place. You will not be able to cultivate potatoes, but you can cultivate energy crops, and the energy crops make place on the mineral soils for potatoes. And then you have also solved the problem. You have to think in this type of solutions.
Right. Yeah. Thanks. It's excellent points, Prof. Joosten. Saya akan membacakan 2 pertanyaan lagi. Ini tadi pertanyaan dari Mbak Rahma Fitri Nur dari YouTube yang kami angkat. Sekarang 1 pertanyaan lagi dari YouTube tentang inovasi atau terobosan yang sudah dilakukan di Gambut yang mampu meningkatkan ekonomi masyarakat sekitar. Ini pertanyaan yang mendasar juga. Nanti mungkin Pak Deputi bisa mengelaborasi. Ini dari pertanyaan dari Sylvia Nuryasari dari Lampung yang kami angkat dari YouTube. Kemudian yang dari chat yang belum sempat diangkat, kemudian bukannya itu, ya ada lagi. Dari Alma Gawe mengenai rice farming, apakah bisa dimasukkan dalam kategori polyculture? Saya mungkin ini Prof. Maas yang bisa mengelaborasi ini. Apakah rice farming itu bisa masuk polyculture, Prof. Maas? Jadi 2 pertanyaan ini, yang satu dari YouTube, yang satu Almage dari YouTube juga ya, dari YouTube juga yang banyak. Karena di dalam chat sudah banyak dielaborasi Prof. Joosten. Kami persilahkan Pak Haris dan Pak Prof. Maas setelah itu.
Ya, terima kasih Pak Nuk, Bapak Ibu yang memberikan respon dan pertanyaan. Apakah inovasi-inovasi yang sudah tersedia dari kegiatan-kegiatan dan aktivitas yang terkait dengan kegiatan ekonomi masyarakat, barangkali kita perlu juga menyampaikan kepada kita semua, memang inovasi itu adalah sebuah perubahan. Jadi kita sederhananya saja kalau di lapangan atau di kampung-kampung masyarakat sudah mulai banyak mengembangkan komoditas-komoditas yang ramah gambut, yang sudah mulai mengerti tentang pentingnya air di lahan gambut. Itu juga merupakan bagian dari satu inovasi yang terjadi di tingkat yang paling di level masyarakat. Tetapi memang ketika produk-produk ini inovasi itu bisa diterjemahkan sebagai produk-produk hilirisasinya. Ya, banyak sekali yang mungkin sedang sekarang ongoing untuk sagu, berbagai macam produk turunannya sedang dikembangkan untuk kepentingan diversifikasi berbagai macam olahan sagu, dan juga kita mempertimbangkan bagaimana sagu itu juga untuk ramah plastik, produk ramah lingkungan, dan juga ada beberapa produk-produk purun yang itu bisa dikemas lebih menarik dan juga lebih punya nilai jual yang lebih baik, termasuk juga produk-produk turunan lainnya dari gambut, misalnya madu dan hal-hal yang lainnya. Yang lebih juga kami perlu informasikan adalah Badan Restorasi Gambut selalu menggunakan pendekatan yang terintegrasi antara bagaimana memulihkan gambut juga merevitalisasi ekonomi masyarakat. Merevitalisasi ekonomi masyarakat ini memang berbagai macam upaya yang sudah dikerjakan dan terus akan ditingkatkan. Memang problem dasarnya adalah kita pada aspek hilirisasi, pada aspek pemasaran, dan perlu ini keterlibatan para peneliti dan para katakanlah inovator-inovator, anak-anak muda untuk melakukan terobosan yang bisa membantu pengembangan ekonomi di desa-desa peduli gambut di lingkup Badan Kerja, di lingkup kerja restorasi gambut. Itu Pak Nugroho.
Ya, terima kasih Pak Aris. Prof. Maas mungkin bisa menyampaikan, sebelum Prof. Maas menyampaikan elaborasinya, saya masih membuka kesempatan untuk raise hand untuk tampil secara visual, karena belum ada yang raise hand. Saya masih tunggu dan akan saya beri kesempatan. Sambil menunggu, saya persilahkan Prof. Maas untuk menyampaikan elaborasinya. Silakan, Prof.
Ya, jadi yang pertama itu adalah kita tahu bahwa jumlah kesatuan hidrologis gambut itu ada 24 juta hektar. Kemudian terakhir dikatakan gambut yang tebalnya lebih dari 50 cm itu ada 14 juta. Jadi artinya ada 10 juta itu yang gambut atau mineral dengan gambut ketebalannya kurang dari 50 cm. Dan ini adalah suatu challenge yang bisa dimanfaatkan. Jadi bukan hanya batasan 3 meter saja, tetapi yang paling penting itu adalah bagaimana mengkeep zonasi ini supaya segera ditetapkan dan yang para pelaku di sana itu mematuhi itu. Itu yang konsep-konsep yang ke depan itu harus dikerjakan. Kemudian gambut itu punya masalah dengan rendahnya daya pegang nutrisi. Karena dia 90% itu air dan rongga. Sehingga kalaupun ada diberikan input itu biasanya larinya cepat. Nah, jadi artinya dalam mengusahakan gambut ini untuk tanaman, janganlah tanaman itu adalah tanaman monokultur. Dan paluriculture sangat bagus, tetapi ini juga paluriculture yang konsepnya itu multiple cropping. Ya, karena bisa saja dia saling berbagi nutrisi. Kalau monokultur itu semuanya meminta. Dan semuanya itu harus diberikan dari luar. Ya, kalau ingin sesuai dengan kebutuhan tanaman. Kemudian untuk padi itu memang habitatnya itu adalah kondisi kecuali gogo ya, kondisinya itu memang harus ada air di permukaan atau saturated ya. Saya nggak tahu ini habitatnya memang sudah begitu, bukan tanaman yang dikondisikan dalam kondisi wet, tapi memang tanaman yang kondisinya itu menghendaki wet dan itu sudah dari dahulu karena itu begitu. Jadi saya nggak konsep paluriculture itu adalah bagaimana lahan itu dibasahkan dan ditanami dengan tanaman yang adaptif ya. Kalau memang itu konsepnya maka padi pun itu bisa masuk. Tetapi masalahnya adalah padi ini menghendaki nutrisi yang tidak bergerak. Sedangkan di gambut nutrisinya itu bergerak karena airnya tidak dapat dipertahankan menetap. Jadi itu sebabnya jarang yang berhasil bertanam padi dan gambut, terutama gambut-gambut yang lebih tebal dari 1 meter. Membuat airnya itu tetap dan ada nutrisinya tetap tidak lari itu yang sulit. Terima kasih.
Terima kasih, Prof. Ini sangat jelas antara ketersediaan nutrisi dan air, penjelasan Prof. Maas. Masih saya buka kesempatan untuk tampil, raise hand. Barangkali ada yang mau menyampaikan sesuatu, tampil secara visual, dipersilahkan di raise hand kalau ada. Ya.
Pak Budi, Pak Nuk.
Ya,
Pak Budi Triadi.
Silakan. Ya, Pak Budi Triadi. Di situ nggak ada raise hand-nya yang ada. Silakan Pak Budi.
Ya, baik. Terima kasih, Pak Nugroho. Good morning, Mr. Hans Joosten.
Morning.
Thank you for your nice presentation. As you have mentioned, there is a 10 centimeter lowering of the groundwater table causes emission of 9 tons per hectare in Indonesia. Furthermore, can you provide information about the correlation between 3 variables, groundwater level, subsidence, and the amount of carbon emission? That's my first question. And the second, as you know, in Indonesia, there are many oil palm and acacia plantations. What is your opinion about this, especially for applying the paluriculture system and wet peatland so that both of plantation and paluriculture can work together? And the third, I'm a little bit surprised about this statement Is that true that Indonesia carbon emission from peatlands are the largest in the world? What do you think about carbon emission in the USA and China? Thank you very much.
Terima kasih Pak Budi. Pak Asmadi mau menyampaikan sesuatu, Pak Asmadi? Kelihatannya.
Yes. So there are three questions.
Yeah.
Okay.
One more person.
Okay.
Prof,
Okay. Asmadi-san. Okay.
One more person. Ya.
Yeah.
Silakan.
Yeah. I asked for Hans Joosten consider the experience how they stops the peatland in Europe. 2018, I joined the international more expression in the Poland. I see many destruction in the Netherlands, Germany, and Poland. I hope you can share this and how to do that so Indonesia not make the mistake for the future. Yeah, I think thank you, Hans.
Okay, terima kasih Pak Asmadi. Please, Prof. Hans Joosten, you can answer 2%, 4 questions for you.
Yeah, if I still remember the questions. So the first question is, what is the relation between water level, CO2, and subsidence?
Yeah.
Of course, there are other factors that influences emissions and subsidence, but the most important factor is the water level. And it is so, like I said, that in general in the tropics, with every 10 centimeters that you lower in annual average, the water level, that 9 tons of CO2 equivalent more comes out of it. Yeah. And subsidence is actually directly coupled to emissions. The more your subsidence is, the more your emissions, at least when you are in a balanced system. Of course, when you start draining a peatland, the subsidence is caused by compaction, simply because you get water out of it. But if you are, for example, in a persistent palm oil plantation or in a pulpwood plantation, actually your annual subsidence can directly be recalculated in annual CO2 emissions. There's a very nice paper about that by John Kouwenberg and Alyosha Hoyer, where they worked this out for palm oil plantations. So the initial subsidence is, of course, caused by compaction, but the ultimate subsidence in a stable economic system is actually directly oxidation and causing CO2. So there is a one-to-one link between subsidence and CO2 equivalent emissions. So the other question that Pak Budi Triadi came with was, what do we have to do with these pulpwood and palm oil plantations? These are, of course, the dominant economic drivers of peatland drainage, and it is the most extensive area. Yeah, I think whatever you do, they do not have a future. Of course, you can continue cultivating pulpwood under drained conditions and oil palm under drained conditions, but then you will lose every year a specific number of centimeters of height. And it is simply a calculation how long it will take that the sea will flood your peatland, or how long it will take that because of limited height differences to the sea, you cannot drain it anymore with gravity drainage. You can calculate that. The RSPO has already in its rules said, if you come to the situation that after the next round you cannot drain your area anymore, then you are not allowed to plant palm oil again. So this is well known. You are going down. If you continue drained peatland use, you're going down, and if you are going down, you will end up in the sea if you are close to the sea. And if you are not close to the sea, you will end up in water, in lakes, like we also see in several areas after burning, etc. Or you will end up in central Kalimantan, you will end up on white sand that is completely infertile. So you get problems with white sand infertile, you get problems with acid sulfate soils near the sea as soon as you touch the mineral soil, or you will be flooded by the sea. So this is not a perspective. they will drive themselves out of the market unless they change. And then the question is, in which direction do they have to change? I already in the chat discussed it a little bit. I know that pulpwood companies, some of them, Asian Pulp and Paper, for example, have been experimenting with finding alternative in the tropical peatland forest of tree species, shrub species that can replace acacia under very wet conditions. Then the question may be, maybe these species are not as productive as the acacias. But first, this is a matter of selection and cultivation. Of course, also these acacia species, they have been cultivated through and selected, and palm oil even more. Of course, we have had an enormous increase of productivity simply by agricultural selection. That can be also applied on these wet species. And secondly, even if the revenues are less, if your alternative is that you have nothing in the future, you can better have half forever than in the end you have more than have everything now and nothing anymore in 30 years. So that is the consideration that you have to take. In Europe, we have exactly the same problems. In Europe, we have large areas drained. Not for nothing is Europe the second emitter of greenhouse gases after Indonesia. Why Indonesia? First, Indonesia is a very big country. We all know that. You have drained tens and tens of millions of hectares of peatlands. But also, Indonesia is a warm country. You do not have winter. In the winter, nothing happens in Europe. It is too cold for microbes to function. So that is the reason that these processes are going much faster in the tropics than in Europe. In Southern Europe, where it is warmer, we hardly do have peatlands. It's too dry there. But in Northern Europe, where we have most of the peatlands, they are under snow half of the year. Nothing is happening there. That is the reason why these emissions from peatlands in Indonesia are relatively per hectare much larger than in Europe. But as I said, the challenges are the same. We are going down, we have large emissions, etc. So the emissions from agricultural peatlands in Germany, they are twice as high as the emission of the third dirtiest energy plant in Europe. So it is really substantial where we are talking about. So these have to be addressed. And there it is also looking to new crops that can thrive under wet conditions. We do not have them yet. We have ideas. But all the things that we apply now, like Tifa, like Phragmites, like Sphagnum, like Alder, it is something we have taken from the wild. We have not done agricultural practices with them, select them on suitability, select them on productivity, thought about how to cultivate them that they produce as much as possible. We are in the Neolithicum of paludiculture. But we also see that we can use all the techniques, all the insight that agriculture has gathered over the last centuries, the new methods of improving your cultivation, and we can apply them to paludiculture crops, and we see that the development is very quickly. I have myself here behind my back, you cannot see it because there's a bookshelf there, we have 800 species of sphagnum and clones. We have said we can make it viable economically if we increase productivity from these wild species with 30%. We have reached 40% already after 3 years. So you see that there is a lot of possibilities there, and you have to focus in that. You have to put your research and development concentration on that, and then you will find the solution. The nice thing of Southeast Asia is you have so many species. Wim Giese has made a very nice inventory on what kind of economic interesting crops are growing in these peat swamp forests, hundreds of them. You have to find them, you have to select them, and you have to cultivate them as alternatives for your oil palm and your pulpwood on peat. But there was a fourth question and I have forgotten that.
Pak Asmadi, bisa singkat saja Pak Asmadi. menyampaikannya. Beliau lupa, nggak taking notes.
Yeah, I would like to information from the Professor Jan Hastens how the experience in Europe to manage the peatlands. They have a long time ago have to use the peatlands. So we do not like to do the mistake in Indonesia or the tropical peatlands. Yeah, I see some place in the Netherlands, in Germany, and the Poland 2018 which May international more excursions that time.
Terima
Thank you.
kasih Pak Asmadi. Ya, poinnya bagus sekali. What's experience in the Europe we can learn from that. One more question, Prof. Joosten. It's related to that. From the chat. Can you give your estimation? Yeah, what Indonesia peatlands are going to be in the future if, let's say, 50 years from now, if business is going to be as usual in peatland utilization. So like Pak Asmadi asked about lesson learned from Europe, and this Pak Dr. Surya asked about the estimation in the next, say, 50 years Indonesia when we are doing business as usual. So please, Prof. Joosten.
There is one nice rule that you have to keep in mind. There is not such a thing as a sustainable drained peatland. Every peatland will either be wet if you continue draining it, because it goes down so deep that you cannot drain it anymore. It will be flooded by the sea, or what is happening here, flooded by the rivers, etc. So it will anyhow become wet, but uncontrolled. With polluticulture, you control it on a level that you want to have it, or it will not be a peatland anymore. That all the peat has been oxidized. And we have in the Netherlands had 1.5 million hectares of peatlands. After 1,000 years of drainage, only 200,000 hectares are left. The rest, all the peat has gone, and you are on the mineral subsoil. And then the question is, what is this mineral subsoil? Is that interesting for you? There are two mineral subsoils that are completely uninteresting from an Indonesian perspective, and that is infertile sand. We have the same in Brandenburg surrounding Berlin. There the farmers are re-wetting the peatlands because they know when the peat is gone, there is white sand below that is completely infertile. And the alternative, the other thing in Indonesia, very important, is acid sulfate soils near the coast. Also very uninteresting from a farmer's point of view. So you want to avoid that.
Right. Thank you, Prof. Joosten. I think we already passed to the finish. I mean, it's 20 minutes past 4 now. So we have to finish our discussion. Thank you very much, Prof. Joosten. I'd like to wrap up of some points in this discussion. We'll be using to make conclusion in the next series of discussion. Jadi Ibu dan Bapak, kami akan mencoba membungkus beberapa poin, tetapi saya tidak akan mereview lagi. Hanya kita sepakat bahwa dari 2 jam pembelajaran ini kita banyak belajar dari apa yang diceritakan Prof. Joosten, terutama di Eropa, bagaimana perjalanan perubahan paradigmanya, bagaimana lesson learn-nya Belanda yang 1,5 juta hektar tinggal 200 hektar, yang terakhir tadi bagaimana kita bisa menggunakan inovasi-inovasi, dan itu diproyeksikan juga dengan problem-problem pengelolaan gambut yang sekarang kita hadapi. Misalnya kita akan mengutilize untuk tanaman pangan, padi terutama, ya. Beberapa poin tadi sudah diberikan oleh Prof. Maas, apa-apa yang perlu menjadi catatan, ya. Jadi itulah beberapa poin yang bisa kita angkat dari diskusi ini, pembelajaran dari subtropika dan tropika yang bisa kita adopt dan bisa menjadi catatan bagi kita dalam mengelola ekosistem gambut ini. Saya kira itu makro dari pembungkus diskusi 2 jam ini atau wrap up dari ini. Teman-teman saya dalam satu tim akan mencatat beberapa points yang walaupun mungkin tidak bisa menjadi satu kesatuan yang konvergen, tetapi paling tidak beberapa points ini akan kami bungkus bersama, dan di akhir kita akan mendapatkan sesuatu yang valuable untuk perjalanan riset ke depan. Saya kira itu beberapa hal yang bisa kami sampaikan. Again, Prof. Hans Joosten, thank you very much for being here, being in the webinar, virtual room. So thanks for your opinion and lesson learned that you share to us. Yeah, thank you very much. Terima kasih dan Bapak sekalian. Wassalamualaikum warahmatullahi wabarakatuh. Salam santi.